The broadcast is now starting. All attendees are in listen-only mode.
Good day and welcome to the December Pacific Northwest DEWS Drought and Climate Outlook webinar. My name is Britt Parker and I'm with the National Integrated Drought Information System. This bi-monthly webinar series hosted by NIDIS, the USDA Northwest Climate Hub, and Oregon Climate Change Research Institute, is designed to provide partners and other interested parties in the Pacific Northwest with timely drought and climate information. Each webinar will be tailored to reflect recent, current, and forecasted conditions and climatic events, but will also include discussions of observed impacts and other relevant updates from across the region. Webinars and recordings and other supporting materials will be posted on drought.gov later this week, and you should receive an email with links to the recording and information. Note that after today's webinar, you will have the opportunity to provide feedback that will help us improve this webinar series. So please take a moment and tell us what you think. Today, we have a series of speakers. We're doing things a little bit differently. We'll start off with our traditional climate recap and current conditions with Zach Hoylman from the Montana Climate Office and the University of Montana, and then move on to Andrea Baer, who will give us the seasonal conditions and climate outlook from the NOAA National Weather Service Western region. Then we'll pause and take questions on those two presentations, and then we'll move on to a series of short presentations on specific condition and outlook highlights as we head into winter from the three states. David Hokema will speak from the Idaho Water Resources Department, Karen Bumbacco from the Office of the Washington State Climatologist and University of Washington, and we'll finish up with Larry O'Neill from the Oregon Climate Service and Oregon State University. We will be using the Q&A box at the right of your screen for questions during the presentation. And as I said, we'll address those in groups as we go through the presentations. And then, of course, if you do have questions that you didn't get typed out for the first two speakers, we'll, of course, take those at the end as well. Before we begin the presentations, we wanted to highlight the partners who make this webinar series possible. The Northwest Climate Hub develops and delivers science-based, region-specific technologies and practical information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Washington, Oregon, and Alaska. Visit the website listed here to get more information, and we'll also put that in the chat box. The Oregon Climate Change Research Institute is a network of dozens of researchers at Oregon's public universities that work closely with other public and private entities. OCRI is housed at Oregon State University. OCRI advances understanding of regional climate, impacts, and adaptation, and cultivates climate-informed communities. The NIDIS mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS is building the foundation of a national drought early warning system through the development of regional DEWS, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is a national early warning system, we recognize that the impacts and early warning information differ across regions. Each DEWS has many of the same base ingredients, but ultimately have their own flavor to reflect the needs of their regions. The Pacific Northwest DEWS was officially launched in February of 2016, and you can explore our strategic plan and current activities on drought.gov. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join COCOROS, the Community Collaborative Rain, Hail, and Snow Network. This is a unique nonprofit community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, rain, hail, and snow, as well as condition reporting. Observations by COCOROS observers of precipitation events and the lack of precipitation are important to capture and improve our understanding of weather. To become a volunteer or to learn more, visit cocoros.org or contact your state coordinator, and we will put those emails and names in the chat box shortly. Finally, we would love for you to help the USDA Climate Hub by filling out a survey on their website usability. The goal is to improve content delivery, and the survey is only 8 questions and should take less than 10 minutes, to complete. We'll also put the information on this survey into the chat box and would very much appreciate your input. So with that, let me stop presenting. And I am going to change and give, actually, I'm going to display Zach's presentation. Excuse me, give me 1 second. And Zach, I will turn it over to you.
Great, thank you, Britt. And I'm just checking my mic. Can you hear me?
Yes, I can.
Okay, fantastic. Thank you so much, Britt. My name is Zach Hoylman, and I'm the Assistant State Climatologist in Montana. And I'm excited to be here today to kick off the climate and current conditions recap for the Pacific Northwest DEWS. Drought has been a persistent feature of this landscape for over 2 years now, as you all know. And while it's been unseasonably cold the last several weeks, much of the area has received below average precipitation in the short term, and long-term precipitation deficits remain across large portions of the area. Next slide, please. Thank you. My presentation today, back 1 slide, thanks. My presentation today will focus on how conditions we've experienced over the last couple of months compare to historical conditions. And specifically, I'll focus on the last 90 days and 30 days of precipitation and temperature, snowpack, soil moisture, stream flow dynamics, and drought conditions. I'm going to attempt to do all this in 10 minutes and then hand it off to Andrea for the discussion of the seasonal outlook. Next slide, please. So let's start with what we've experienced over the last couple of months, and more specifically, the last 90 days. In this slide up left, I've shown temperature departure from normal for the last 90 days compared to the 1991 to 2020 climate normal. White to blue shading represents cooler than normal temperatures, and red shading indicates warmer than normal temperatures. Overall, you can see that the western portions of the domain in Washington and Oregon have experienced warmer than normal temperatures, mostly driven by conditions in September and October. Contrary to this, South Central Oregon and Central Idaho have experienced cooler than normal temperatures. The figure on the right shows our anomalies in precipitation for the last 90 days. Increasingly, brown areas represent below normal precipitation, white areas represent normal precipitation, and green areas represent above normal precipitation. I'll call your attention to the area of brown extending from northwestern Washington south along the coast throughout Oregon. Here, precipitation has been well below normal, with only 50 to 70% of normal for the last 90 days, though some locations are slightly below normal. On the other hand, Central Idaho, along with the central border of Washington and Oregon, have experienced wetter than normal conditions, with values ranging from 110 to over 200% of normal precipitation. Next slide, please. As we transition to the last 30 days, we see similar precipitation patterns across the domain. However, temperature anomalies differ considerably. Starting with temperature on the left, you can see that the entire domain has generally experienced below average temperatures, ranging from a normal to a whopping 9 degrees cooler than average. Large portions of central Washington and south central Oregon experience well below normal temperatures. It's been a cool start to the winter, to say the least. In fact, November has been the 4th coldest on record for Idaho, 6th coldest for Oregon, and 7th coldest for Washington based on the last 128 years, according to the National Center for Environmental Information, or NCEI. Precipitation deficits over the last 30 days, so switching over to the right-hand figure, again show similar patterns to those observed at 90 days. Generally, western Washington, Oregon, and Idaho Panhandle regions and western Montana have received lesser than average precipitation. However, portions of central Washington, eastern Oregon, and central Idaho have experienced greater than average precipitation. Next slide, please. So how have these cool conditions impacted the start of the snow season? Well, on the left, I'm showing the percent of average snow water equivalent, or SWE, for December 15th across the mountainous regions of the Pacific Northwest. These data are measured using snow pillows at SNOWTEL sites across the Rocky Mountains and Cascades. You can think of snow water equivalent as the amount of water that would exist as a depth if you were to melt the entire snowpack at a specific point. On the right, I'm showing a slightly different estimate of SWE anomalies calculated using a snow model maintained by NOAA called SNODAS. Let's start by looking at the SNOTEL data on the left. This figure shows the average snow water equivalent for each hydrologic unit code, or HUC6 watershed. Yellow and orange shading indicates below normal snowpack conditions, green indicates normal conditions, and blue indicates above normal conditions. As you can see, we were off to a good start to the snow season. Almost all basins are at or above normal SWE for the date, with the exception of the northerly-most sections of western Montana and one basin in northwestern Washington. Snowpack is well above average across Oregon and southern Idaho. Let's shift to the right-hand figure now and look at the SNODAS dataset. The SNODAS model takes an assimilation approach to estimating snowpack dynamics, leveraging both the snowpack model as well as observations from datasets such as SNOTEL. The main difference here is that compared to SNOTEL is that SNODAS estimates snowpack across the entire basin from low to high elevations. Here we can see a similar story to SNOTEL, where snowpack is generally at or above normal, shown with those cooler colors. However, this model is also indicating that mid to low elevation snowpacks have been the quote-unquote big winners so far this season. Anecdotally, I can confirm these results in western Montana, where our low elevation trailheads where we go skiing quite often are looking a lot like midwinter conditions, and it's only December. As encouraging as these data sets may be, I need to stress that it's still very early in the season and we have a long way to go before we can say how this snowpack will ultimately shake out. Next slide, please. The persistent drought conditions continuing from last year in conjunction with the lack of significantly above average precipitation have set the stage for average to dry soil moisture conditions across the Pacific Northwest. In this slide, I've shown the Climate Prediction Center's modeled soil moisture percentiles for December 15th on the left, and soil moisture anomalies from the U.S. Forest Service soil moisture product called TopoFire on the right. Starting on the left, red colors represent below average conditions, while green colors represent above average conditions. As you can see, soil moisture is generally below average in the western portions of the domain, with wetter than average conditions in east central Idaho. Shifting to the right, the TopoFire-based soil moisture anomalies are generally similar, but negative anomalies, meaning drier conditions, in West Washington and Oregon are typically farther to the east. Next slide, please. Looking directly at current stream flow conditions, here's a map of USGS stream gauges and flow rankings across the Pacific Northwest for the last 28 days. Across the gauge network, blue symbols indicate greater than 90th percentile flows for this same time period, or well above average stream flow. Light blue is between the 75th and 90th. Green is the 25th to 75th. Orange is the 10th to 25th percentile, and red is the 10th percentile, or well below average. Generally, the majority of gauges across Washington, Idaho, and Western Oregon are recording below to well below normal stream flow, with a few exceptions. Stream flow conditions are especially low in the northwestern portions of Washington, southwestern portions of Oregon, and across southeastern Idaho. Next slide, please. Summing all these observations up, we can take a look at last week's Drought Monitor map drawn up by Curtis Rigonanti. As you can see, drought continues to be persistent across the Pacific Northwest despite cooler than average conditions over the last several weeks. Low stream flow, dry soils, and precipitation deficits over the last 3 to 12 to even 24 months and even longer have produced wide regions of severe or D2 and extreme or D3 drought conditions in Oregon. In Washington, a few slivers of moderate drought, or D1, exist along the western portions of the state. Idaho is generally experiencing widespread moderate to severe drought conditions, especially in the southern portions of the domain. Next slide, please. But what recent trends are we seeing in the USDM? On the left, I'm showing you a 3-month change map of USDM classes, showing if drought is getting worse or better, and on the right, a 1-month change map. Starting on the left, you can see that drought has generally intensified across western Washington and northwest Oregon over the last 3 months, indicated using those yellow colors. However, drought has been ameliorating or getting better across southwestern Oregon and along the Oregon-Washington border. Months. More recently, conditions have been improving slightly, likely due to encouraging start to the snow accumulation season as seen on the right-hand side figure. Next slide, please. So in conclusion, temperatures, starting with temperature, it's been cooler than normal over the last 90 days across south central portions of the domain and warmer than average across the western portions of the domain. In the last 30 days, we've seen well below normal temperatures across the entire area. Precipitation, 90-day precipitation dynamics generally follow temperature, and we've seen drier than normal conditions in the western portions and wetter than normal conditions in the southeasterly portions. And there's a kind of a similar story in terms of those spatial patterns over the last 30 days. And these conditions have caused recent deficits have caused reduced soil moisture, reduced stream flow, especially in the Washington, Oregon Cascades. And however, snowpack is showing an encouraging start to the accumulation year, but again, it's very early in the season, and we have a lot longer of a wintertime season to see how snowpack is ultimately going to shake out. And with that, I'll say thank you and pass it on to the next presenter.
Great, thank you, Zach. We will pass it on now to Andrea to talk about the outlook.
Okay, let me put this in presentation mode. Can you hear me, Britt?
Yes, we can hear you.
Okay, it's thinking about it. Come on, there we go. Okay, good morning, everyone. My name is Andrea Bear. I'm with the National Weather Service at our Western Region Headquarters office, and I'm going to talk to you a little bit about the climate and the drought outlooks for the next couple of months. The big player right now in the climate world is La Niña. We are in our third year of La Niña. That hasn't happened very often. I'll show you a couple of other times that's happened in the presentation in a minute, but definitely rare for us to have 3 in a row. So I'm going to get to the status quickly. I'll put this at the end as well, but we are in a La Niña advisory, meaning La Niña is present. The sea surface temperatures off of the equatorial Pacific Ocean are below average for much of that tropical Pacific, and the atmosphere is consistent with La Niña, meaning we've been seeing more rain than average in Indonesia, drier over the Central Pacific, and the trade winds have been much stronger for the last several months. We expect La Niña to continue into the winter and then transition to ENSO neutral, or when we don't have La Niña or El Nino, sometime in the spring. So looking at current conditions, I want you to look at this Niño 3.4 area. That's roughly right here where my cursor is pointing, where this is outlined. That's the section of the ocean we're looking at there, and the one we most commonly look at for the US to determine El Nino or La Niña conditions. And as you can see, we're at about -0.9. We're starting to get a little bit warmer at the sea surface, but pretty cool through the entire year this year. So looking at the subsurface, so from the surface of the ocean down to about 300 meters in the Pacific, you can definitely see this cooling that has been taking place, quite cool in the subsurface. But lately it has definitely warmed a bit, and that just means the sea surface temperatures are starting to warm up. We're starting to transition ocean-wise into probably more of an ENSO neutral territory. The reason for this is likely we had in about the mid November timeframe, we had an easing of some of those trade winds, the winds that blow from east to west, and that's likely helped to increase the warmth at the sea surface, and then as we go to the down to about 300 meters. Hopefully that made sense. As we look at the forecast for La Niña, you can see for the November, December, January, firmly La Niña, but as we get into January, February, and March, we start to see that transition. And as we go into the spring, looks like we're forecasting to go back into ENSO neutral territory. You can kind of see El Nino starting to look more favorable as we move into the summer months, but that's a long way off. So I wouldn't put a whole lot of faith into that quite yet, but something to keep an eye on. I do want to stress that while we definitely see trends that happen often during La Nina, there's a lot of variability. These maps show the northern part, so the Pacific Northwest of the United States, and really the variability that we see during La Nina events, whether they be strong, moderate, or weak. You can definitely see typical tendencies that we expect with the cooler temperatures, but also we've definitely had some warm events as well. And this is precipitation. Again, a lot of times we expect that to be the signal to be wetter up there for the Pacific Northwest, but it doesn't always happen that way. If we look at other triple dip or years where we've had a third year of La Nina, there have been 4 cases since the early 1900s, and 2 of which have happened since the 1950s. And what you can really see in the temperatures is definitely the variability. So this would have been the 3rd year in those triple dips, and a couple of them with cooler for a good portion of the Pacific Northwest, but then also warmer for others. So again, just wanted to stress, you really should keep an eye on the shorter term. You can get tendencies from these La Nina forecasts, but you really have to be careful. Don't bet the entire farm on being colder and wetter. It doesn't always happen. So here is the precipitation for those same years, the 3rd years of La Nina. And again, 2 that were wetter and 2 that were drier for the Pacific Northwest. This is a composite map that shows the snow water equivalent during La Nina years. And as you can see, definitely the percent of average is over 100 up to greater than 150% of average for much of the Pacific Northwest during La Nina. So turning now to the outlooks from the Climate Prediction Center, these are the seasonal outlooks. So this would be for the season of January, February, and March in the new year. And these are going to follow the typical La Nina pattern. So they definitely reflect that with the cooler and wetter conditions in the Pacific Northwest. So again, I just want to stress, there is a lot of variability in past events. So it's important to keep your eye on what's going on in the shorter term. These are the weeks 3 and 4 forecasts. So they are valid from New Year's Eve to about January 13th. And they were made last Friday, so they are current, showing above normal temperatures to start the new year out in the Pacific Northwest, and also favoring above normal precipitation there. So this is the 8 to 14 day outlook. And if you go onto the Climate Prediction Center's website, which I have put the link here, and you click on the 8 to 14 day outlooks, this is what you'll see right at this moment. These are about to be updated by the end of this call. And I will say I've seen them this morning, and it does look like we do have a pretty good pattern change coming our way just after Christmas. So starting around the 26th, much of the country, even more so than is indicated on this map, is favored to be above normal temperature-wise, and also above normal is favored for the precipitation, and especially for the Pacific Northwest there. So that is probably good news for those of you who are quite cold right now. Just get through Christmas. And then I will end with the drought outlooks, and I have the monthly there on the left and the seasonal there on the right. And looking at the seasonal down there on the right, it looks like we're going to see some improvement, and a lot of that is based on the tendencies that we get during La Nina years. So either removal likely or remains but improves. And then still, we've got quite a bit of brown, so drought persisting when we look at the month for December. So that will be updated at the end of this month, both of these. So look back on CPC's website for that. And with that, I will end my presentation. If you have any questions, I'm happy to take them. So thank you.
Great. Morgan, while I set up the rest of the presentations, are there any questions?
It doesn't look like there are any questions at this point, but if anyone thinks of any, feel free to put them in the chat and we'll answer them following the final presenters.
Great. So we wanted to give an opportunity for some digging a little deeper into the current conditions and the outlook for each of the three states, the main states in the Pacific Northwest DEWS, especially given the long-term drought we're seeing in some areas of this region. So I first want to turn it over to David Hoekema with the Idaho Department of Water Resources.
Thank you, Britt. Can you hear me?
Yes, I can.
So I'm David Hoekema with the Idaho Department of Water Resources. I'm a hydrologist here. Southern Idaho, we'll focus on Southern Idaho in this presentation, but Southern Idaho has had 2 years of drought, in some portions 3 years of drought. And we've really experienced two flavors of drought. In 2021, we had a pretty decent snowpack. It was a little below normal. It was our first La Nina year, which was unusual to have a La Nina that was that dry. And then spring really shut off. And so we went from having a very full reservoir system to draining really the reservoir system out in 2021. It really helped pull us. That storage pulled us through the season, but we ended 2021 with the reservoir system empty. And then last year, the snowpack was worse, and we had an empty reservoir system, and we really expected pretty severe drought across the state. And we had some a cool and then above normal precip in the Boise Basin and Payette Basin, and they were really the only ones that truly recovered from drought last year. The rest of the state continued on through drought. So if you look at this teacup diagram from the Bureau of Reclamation, this shows the Boise project, which includes both the Boise River and the Payette River, which are tributary to the Snake. The Payette River is typically water rich, and we very rarely worry about drought there. But if you look at the Boise system, you can see it's really in an ideal situation. We've got Anderson Ranch, which is the highest reservoir in the system. That's nearly full. And then the lower systems that are easier to fill, Arrow Rock and Lucky Peak, you know, they're decent for this time of year. We need some flood control space, especially down in Lucky Peak. So we're really set up in a good condition, and you know, unless the snowpack ends up to be totally dismal this year, the Boise Basin should be able to pull through the next season. The rest of the state, though, more resembles the Snake, and we'll go see a couple slides there, but why don't we go on to the next slide, which shows the overall condition of the three largest reservoirs on the Boise system. The blue represents our current year storage, and red represents what is average, and then green represents the previous year. So you can see last year we started out with very low storage, and this year we're already above average. We're not filling rapidly, and of course with this early snow coming in, there will be some concern about flood control as we enter into January. At this point, I don't believe there's any concern yet, but we're above average and we're really in an ideal place. So if we can go to the next slide. Here's our snowpack conditions in the Boise Basin. In Idaho, southern Idaho, we typically peak our snowpack right around April 1st, where you can see the median peak snowpack is that green X. So that's really where we want to go. And you can see last year we were a little behind where we're at now, and then we had some great storms come in, but then that system shut off. And so right now we're closing in on where we were last year. We have a couple of storm systems coming in, so we should get a little spike, but we have a long ways to go. We're only at 40% of that peak. And so, you know, there is concern whether or not we'll have a normal snowpack, but unless we could probably go just a little below normal and pull through the next year, since we have the strong carryover. Now, if we move down to the Snake River system, which in a large part represents southern Idaho as well, which I won't show, you know, the reservoir system is very different. If you look at the reservoirs at the top of the system, they're empty, and it will be quite difficult to fill those reservoirs. We're going to need a snowpack, we estimate, around 120% of normal if we're going to recover from drought. Can we go on to the next slide? And so if you look at the snowpack, where we're at, it's not quite as good as on the Boise, but we're pretty close to average for this time of year, and we have a long ways to go. Is there one more slide, Brett? I thought I had a slide showing the overall fill on the reservoir system, but basically this Snake River system is about 1 million acre-feet short of normal. And this represents kind of the rest of southern Idaho. Our reservoir systems are really drained out after 2 years of drought. And so one of our big concerns is if you look at consecutive La Niñas in southern Idaho, they have all been drier as each La Niña progresses. With the exception in the 50s, we did have quite a jump in a consecutive La Niña where the second was wetter. Hopefully we'll see that this year. But you know, the overall trend is not great, and we have a long ways to go on snowpack. We're only at 34% of normal on the Snake. We have plenty of time to build that snowpack, but we sure want to avoid seeing a drying out like we did last year. And so we probably won't recommend any improvement in drought conditions until we get into January, maybe even February, unless snow goes crazy. But we're really looking to get above this red zone here before March 1st, this kind of peak. If we were in the yellow by March 1st, around the peak period here, that's when we'll start recommending an improvement in drought. We just have such a deficit in our reservoir systems that we're probably going to encourage holding drought conditions across southern Idaho until at least mid snowpack buildup period around March 1st. Okay, thank you. That's all I have.
Great, thank you, David. And sorry there wasn't another slide. I was muted, so you didn't hear me say that. But we will move next to Washington with Karen Bumbacco.
Yeah, thanks, Britt. This is Karen here with the Office of the Washington State Climatologist. Go ahead to the next slide, please. So Zach set up the kind of recap really well for Washington, but I did just want to point out one factor that we found interesting from this fall. So the plot on the upper left-hand side there is our October mean temperature difference from normal. So really warm throughout all of the Pacific Northwest. For Washington alone, our anomaly was 6.6 degrees Fahrenheit, averaged over Washington state above normal for the month of October. So really warm anomaly. And then it flipped for November. So below is November, showing those colder than normal temperatures and that have persisted through most of December as well. But this is just for November, where averaged over Washington state, we were 5.1 degrees Fahrenheit below normal. So in our recent newsletter, we get this question a lot about increasing variability in temperatures, and is that changing? So we looked at all 4 seasons. This is, again, just for Washington. And on the right-hand side there, that kind of brownish color is looking back at all of the falls back to 1895 and looking at temperature fluctuations in that season. So had there been a similar switch from a really warm month to a really cold month in the fall. And we found that in 2022, the one that we just, the season that just passed, there was an 11 degree difference in anomalies switch. And this is all relative to the same anomaly period of 1991 to 2020. And that was the biggest sort of switch in fall that we've seen going all the way back. So just kind of an interesting record there. Summer is also shown on this plot in our newsletter. You can check to see winter and spring. When I look at this, we didn't do an official trend analysis, but I don't see a real trend in terms of increasing or decreasing variability and kind of these sorts of temperature anomaly fluctuations. But we've been asked that sort of question, which is why we were curious about it. Go ahead to the next slide. So looking kind of where we are now, Zach again showed our snowpack for Washington State. We are seeing a little bit running a little below normal in kind of the northern Cascades there. This is as of Friday. And one measure of drought recovery is through this tool shown on the right-hand side from NCEI, the drought termination tool, that shows like how much precipitation we would need to end drought conditions as measured by one of the Palmer hydrologic indices in 4 months. So looking across the region, it's not looking that great in terms of completely getting out of these deficits, which in some places have existed for multiple years. So for Washington in particular, we need about 150% of our normal precipitation to dig us out of those deficits that we saw beginning this summer and that have extended into early fall by April. The probability of that happening is, for this particular measure, is less than 2%. However, I am a bit more optimistic than that because we do have such good snowpack. And what Andrea showed, hopefully we will get a switch to more precipitation in Western Washington and throughout the rest of the state to and start to improve drought conditions. But there is that deficit that began from summer and extended into fall that kind of put us in this not so great spot despite having normal snowpack. And then my last slide here, I just wanted to point out another issue that Zach did touch on is the low soil moisture throughout the region. So this is one spot, Burnt Mountain. It's on the west slopes of the Washington Cascades, and the plot on the left is our soil saturation at an 8-inch depth for this water year. So compared to all of those colors that are shaded are percentiles from previous records. And at this site in particular, that black trace following this season, we're at really low soil moisture there, below the kind of worst season on record for that particular station. And that's because we did have such a dry summer and fall. So once we did turn cold and started to get snow, it was on top of dry soils, which could be an issue in the springtime. Once that snow does melt out, if you have drier soils, supposedly the soil will uptake a little bit more of that moisture, and not as much will run off as stream flow. On the bottom right-hand side, that is that same site, and their snow water equivalent, the black trace there, is in the kind of dark blue shading, showing that it's much above normal for the snow water equivalent, which is great, but it's on top of these dry soils. So it is something we're keeping an eye on. And we'll see how that plays out this spring. And that's all I had.
Thank you.
Oh, wait,
Yep.
I had one more thing. I'm glad I remembered. I didn't have a slide on it, but I did want to mention that also the good news for Washington is the Yakima reservoirs are right at normal as of now. So we are not seeing as big of an issue in terms of not having good carryover like David was talking about for Idaho. Our reservoirs are in better shape in Washington. So just to note that. And for real, I don't have anything else. Thanks.
Thank you, Karen. So finally, last but not least, we will turn it over to Larry O'Neill from the Oregon Climate Service.
Good day, everyone. My name is Larry O'Neill from Oregon State University, and my email address is here for in case anyone has any questions. And some of the key points I want to make on Oregon's drought conditions and the water year so far is that much of Oregon's reservoir system has relatively little to no carryover going into this water year. So we're really depending on precipitation and snowpack during this winter to get some sort of adequate water supply. Unfortunately, much of the state has had a dry start to the water year, and so this is starting to fuel concern that there'll be more water shortages next year, particularly for irrigation. And as Stack has shown earlier, that despite the lack of precipitation we've had this far, the really cool last 6 weeks or so has fed a really good start to the seasonal snowpack across Oregon. And finally, as Karen mentioned before, much of the state is experiencing very dry soil moisture conditions, and due to the multi-year drought that we are currently in. So next slide, please. So a good start to just summarize the drought conditions across Oregon are from the U.S. Drought Monitor. So this is the most recent depiction across Oregon, and basically 60% of Oregon is in some form of drought currently. And the current trends are that much of Eastern Oregon are showing some slight improvements in a lot of the drought indicators. And so we'll be looking closely at that. However, much of Western Oregon, west of the Cascades, the drought indicators are starting to trend a little bit drier. And so we'll also, considering some degradations going forward. So next slide, please. Basically, one of the impacts of this multi-year drought that we're currently experiencing is very low water storage in Oregon's reservoirs. And this just shows kind of a summary of Oregon's major reservoir systems and how much water is being stored in them. And one of the take-home measures is key points here is that outside of the Willamette project in Northwest Oregon, there's little to no storage in many of the reservoirs. And some particularly, some basins that are in particular trouble right now are the Crooked and Deschutes River basins in Central Oregon, where Pineville and the Wickiup and Crescent Lake are well below normal for this time of year. And we're also running well below normal, or well below what we were at this time last year. And so many of you will recall that there were a lot of irrigation shortages in Central Oregon the last couple summers, and without a lot of precipitation in the remainder of the water year or the wet season, we anticipate those to be an issue, those conditions to be an issue as well going into next summer. And the other problem area is in the Owyhee and Malheur River basins in southeastern Oregon, where the Owyhee and Warren Springs reservoirs are running very low and close to empty. Next slide, please. And so we were really hoping for a good start to the water year and a very complete water year with a lot of precipitation, and that we have not gotten that so far, particularly in Western Oregon, where most regions are below 90% of average precipitation, and in many regions we're actually below 70% of average precipitation. And so now we're coming into kind of the part of the wet season where we're getting the most where we should be getting the most precipitation, and we're not receiving that right now. So these dry conditions right now are very impactful for our outlook for our water season. The exceptions to the dry start to the year are in Eastern Oregon, so particularly in the northeast part of the state, around Umatilla and Morrow counties, and then down into Malheur County and southeast Oregon as well, where we're running well above average precipitation. So next slide, please. So we've heard about the great snowpack in the U.S. West that much of the U.S. West that we've gotten, and that's is here in Oregon as well. So as of this morning, if you just average over all of the snow telemetry stations across Oregon, right now the snow water equivalent is about 141% of normal right now, and all basins are well above average. So this is great news. But the one caveat, of course, is that we're still very early in the water season, and right now we're in the time where we're building up the snowpack at the largest amount. So if we keep having these dry weeks that we've had the last few weeks, then these numbers are going to go down fairly quickly. Next slide, please. And finally, I want to also touch on the soil moisture conditions. And so this just shows the relative ranking of the soil moisture throughout Oregon. So the dark red colors are very poor, very dry soil regions where we've had very dry soil moisture conditions. And the darkest red indicates that we're at what's called the second percentile. And so this is starting to get into historically dry soil moisture conditions. And this has been the same story for the last couple years for all these regions. And so the regions most hit are much of Central Oregon, and then also in the Southwest Oregon Cascades and the South Oregon Cascades and the foothills of them. We've had very poor soil moisture conditions there as well. And we can actually see this reflected in stream flow conditions, and then of course these very low reservoir numbers as well. The exceptions to this is with Northwest Oregon and parts of Northeast Oregon, where we have about average to slightly above average soil moisture conditions, which is great news for those regions, but much of the state is still very dry in terms of that. So that is all I have. Thank you very much.
Great. So I am going to take a look here at the questions. The first question is, will slides and contact information be shared? You need to please reach out to me directly, and I'll put another slide up in 1 second with email addresses for slides. And I'll also have the contact information for each presenter at that time. So stay tuned for that. The next question is, what sensors are used for soil moisture monitoring mentioned in the Washington and Oregon updates? Is there a link that describes the equipment and installations?
Yeah, so this is Karen from Washington. I showed the ones from NRCS. There's not that many sites. I can try and find a link and put it in the chat.
Okay. Great.
And this is Larry from Oregon. And so part of what Karen showed were the soil moisture sensors on snow telemetry or SNOTEL sites. And so if she gets that link, the map I showed is actually from a modeled or observationally based and modeled soil moisture product. And so it incorporates a couple different observations into a land surface hydrology model, which takes into account precipitation, evaporation, and different soil types, and then runoff conditions for all the basins, and then tries to get a map of estimated soil moisture conditions for those regions.
Great, thank you. The next question, and I'll just open this up for any of our panelists, and we can try to follow up and make some connections if we don't have the expertise, but any insights about how the Firmageddon, the loss of millions of acres of fir forests, may affect prospects for ecological drought?
Wow. Britt, I can take a quick stab. This is Zach Hoylman in the Climate Office in Montana. But that's an excellent question and a challenging question. I think we have yet to see how this is all going to affect kind of the retention qualities of the soil. But one perspective I have is forests are known to create what's called a microclimate underneath the forest canopy, and they create what we call biologically driven microclimates. And so in a lot of these forests, you have shading and retention of moisture and reductions in evapotranspiration rates from the soil due to basically the canopy structure of the forest. And so in a lot of cases, when you see these big, large scale kind of regional shifts away from forest land cover dynamics, you'll have a transition towards hotter soil temperature conditions, which can actually impede the kind of establishment of the next cohort of seedlings. It, of course, will open up the ground to a lot more radiation and sun kind of energy, which is going to enhance evapotranspiration. In a lot of cases, that's going to cause kind of the soil to become what we call flashier, which would be that it'll have more extreme wet ups and quicker wet ups due to less interception from the canopy, and then quicker dry downs as well, because there's more of that kind of interaction and interface with the atmosphere. And if you're interested in talking about that further, I'd be happy to follow up. My email is shown on the slide there.
Great, thank you, Zach. The next question is for Larry. When you mention impacts for irrigation in Oregon, does that refer to agriculture, homeowners, residential irrigation, or other groups, or all of these groups?
Yeah, that's a great question. Right now, we're seeing more impacts on irrigation levels. So usually the irrigators, the irrigation allotments are the first to be cut going into spring and summer when we have these really low reservoirs. Some regions do have some municipal, municipal shortages, but that hasn't actually been as big of a problem in Oregon yet so far.
Great, thank you, Larry. Are there any other questions for our panelist? And before we close, I am going to share a couple of the links that Larry and Karen have put in the chat box. I don't think all the participants can see them, so give me 1 second. I'm going to move those over so that...
Britt, there is one more question if you want me to handle the...
Sure, if there's another one.
Chat.
Yep.
The question is, could the panelists talk about dynamics of snow and very cold temperatures falling on dry versus wet soils and implications for either low flows or flooding in the spring?
Oh yeah, I could start. That's a really good question, actually. So in Oregon and in other parts of U.S. West, we rely pretty heavily on rain falling in the fall period before the snowpack sets in to basically recharge the seasonal soil moisture deficit. So basically, the soils dry out during the summer, and then the fall rains come in and saturate or get the soil pretty wet. When the snowpack lays on that, that's usually a good scenario because that means that there'll be more runoff come spring, because instead of the snowmelt soaking into the soils, the runoff will go into the streams and be able to recharge our reservoirs. So for Oregon, that's something we're actually watching pretty closely because as you can see, the precipitation deficits were fairly significant over the fall period. So we didn't really get very much moisture into the soil before the snowpack laid down. So we do expect that there'll be some fairly significant reductions in our runoff efficiencies come springtime and next summer.
Yeah, that's a great answer, Larry. And I'll just add one more thing. I mean, the other side of that, of course, is if you have really, really extreme cold events right before the snowpack kind of starts to fall, you can have a freezing of ice layers in certain portions of the soil column. And when you have really, really frozen soils, in some cases, I would say mostly rare cases, you can have a melt event that then hits a soil ice lens, which then can cause rapid runoff and in some cases flooding. But I think that what Larry highlighted, that ability for dry soils to suck up more moisture, is kind of more of the concern at this point going into the rest of the winter and into next spring.
Great, thank you both. We'll give it one more second to see if any more questions come in. And thanks for pointing out, apologies, Zach, for misspelling your last name, but the email is correct. It's Hoylman. So if you need to get in touch with Zach, that's the correct spelling of his last name. And I don't see any other questions coming in, so thank you all for joining us today and taking time out of your schedule. Please mark your calendars for our next webinar, which will be next year, January 23rd of 2023. And we hope that you all have a safe and good holiday season and Happy New Year, and we will see you next year. Thank you so much.